Alright, today let's do something different because I can't think of anything else to explain. So I explained this paper I've just read. It's Convolutional Neural Network based deep learning method for accurate classification of durian types. Yes, I may have an obsession with durians. Durian season is quite far away. I think it's 2 months or 3 months away, but still, the yearning for durian still exists. So I've decided to find this paper which is able to classify durians, and this can maybe prevent us from being scammed at the durian store, because every single time my family buys durian, somehow the durian isn't the type we want. So they say, oh, it's Mao Shan Wang, it's Musang King, but no, it's not. Every single time it's something different. So with AI, we can fix that. With AI, let's see how far we can go. So this is a paper by the universities in Indonesia, and they probably have more durians than we do. That's why they do this sort of thing. But nonetheless, this isn't a very impressive paper. I think I can do better. And since this is the only paper in that I could find that has some sort of accuracy for classifying durians, this is by right state of the art. And so if I can beat state of the art accuracy, which I think I did in my previous video about the durian classification, but that's a different data set, I could very well beat the state of the art durian classification. Then I would be the best at durian classification. Nonetheless, let's just see how this works. So they start off with an introduction. They just say, oh, durians are good, durians are smelly or smell good depending on who you are, yada yada yada. Numerous benefits. Yes, durians are very good for your health, I think. But yes, here's it. Irresponsible individuals try to provide consumers with incorrect information about durian. So there's a fraud issue that's happening basically, and it's so widely known and so widely prevalent, there's even sources for it. Wow, the sources are, yeah, see, Singapore mentioned, woohoo, but I think basically there's a lot of fraud. That's why they want to do this paper, to see if they can create an AI classification system, and their scope is to have durian recognition and only focus on 3 types of durian species: Musang King, Blackthorn, and D24. Musang King and Blackthorn are different branches of the same sort of durian. Both are considered Musang King, but Blackthorn is a specialized and rarer form of Musang King, while D24 is its own family of durian. So it's quite a unique choice of what types of durian they chose, but I guess that's their decision. And they choose 2 CNN models. They used VGG and exception. Odd choices, given that this was published in 2024 or end 2024. And by then, we've had a lot of newer things like ConvNext or like vision transformers. It wouldn't make sense for them to use exception. And so my bet is this was created by a bunch of uni students for their final year project. Nonetheless, this makes it easier for us to make it better, you know. Next, yeah. They say here that the dataset is quite big. It's 19 gigabytes. I was trying to beat the SOTA just now, but I ran into some issues, most likely because the images were too big, so it was taking a very long time to process. I'll work on that. When I have a working SOTA model, I will probably upload it on the channel. I'll see what I can do about it. But yeah, consumers may avoid being scammed. Very big motivation. So let's actually jump to what they're doing. So despite specifying ResNet here, they do not actually use a ResNet. Instead, they only train the VGG16 model and an exception model. A VGG16 architecture is quite simple. It's shown right here on the screen. It's this chunk. and it is a very deep model. So VGG16, one of the breakthroughs it did was that it's very deep. It was able to reuse a lot of its features and basically create a lot deeper networks, which allowed it to have more powerful representations of the data, which translated means it can make a lot more powerful decisions. Yeah, but as you can see, the performance isn't very good. It's only 56% accuracy because VGG models are quite old. They're from 2014, I think. So they're not the most powerful model. Instead, we have a more recent model. We have the exception model, which is it takes roots from the inception model itself being quite powerful, and it has this bunch of yada yada jargon, which means I actually don't know what that means. It's separating cross-channel and spatial basically it has to do with something with like better mixing of the data across the channels. Translated, it just means it makes use of the data better, and it's a lot more recent model. Yet it only reaches about where's the part? It reaches 92% accuracy. That's not very good. I think we can do better. So I ended off here. What can we improve the data on? We've went through why they did the research. We've went through what they did. They did VGG16 and they did exception model. But they also have a lot of areas of improvement. So here they say they use sorts of data augmentation, including rotations and flips. But rotations and flips are the most basic of visual augmentations. So augmentations are when you adjust or modify the image a bit to make it different so that AI can't memorize the data, so as to actually learn the features that are there instead of memorizing the exact pixels. So modifications like rotations and flips make it harder for the AI to do that. So in real life, we can tell, oh, the image is rotated, but we can still tell it's a durian. But if the AI model just memorizes the pixels, it can't really do that. And so by augmenting the data in this way, we can get better results. However, rotations and flips are just the most basic level of augmentations. We can probably do more things like changes to brightness and contrast. We can shift the colors a bit, although that might affect the accuracy because the color might be quite important for classifying durians. But all in all, with a more advanced model like efficient transformers and more data augmentation techniques, I think we can create a better model for durian classification. Yeah, let's leave it there for today. Hopefully we can improve this result.